Thank you, Fernando. So hello, everyone. I'm Karine Laffont, coordinator of the STUNNING project. Welcome to our STUNNING webinar on integrated, adaptable, and affordable packages for the deep renovation of buildings. As you know, 40 to 45% of Europe's energy consumption comes from buildings, and the building sector is therefore one of the key enablers for achieving low carbon economy goals. However, as said already by Fernando, the annual rate of home and commercial building renovation is still well under the 3% that are required to achieve these goals, and there is a need to accelerate investments in energy efficiency and in renovation solutions to boost cost-effective building renovation that would benefit all European citizens. Different types of innovative renovation technologies are being developed and tested in Europe, and 3 of them will be presented today. What are their distinctive values and why are they cost-effective and effective to enable the efficient renovation of buildings? How can their implementation be supported by tailored and user-centered business models? Those are the questions that we'll try to answer with today's webinar. I will firstly very shortly introduce the STUNNING project. Then Claudio Del Pero, Roberto Fretizzi, and Roberto Lolini will present the HERT, Build Heat, and 4R in EU projects respectively. So let's start with a short introduction of STUNNING, which stands for Sustainable Business Models for the Deep Renovation of Buildings. It's an H20 funded coordination and support action. We started in 2017 and will end in September this year. Its objectives, as already introduced, are first to accelerate the adoption of new business models for the energy efficient renovation of buildings based on integrated, adaptable, and affordable refurbishment package. And another key aspect of the project is to engage with stakeholders of the building value chain. So our approach is summarized on this diagram. So we first reviewed refurbishment cases and demonstrations in Europe and their financing mechanisms. In parallel, the barriers that slow down replication have been analyzed and recommendations on how to address them have been established. Innovative business models have then been identified, and we are now in the process of promoting the most promising ones and illustrating them through detailed case studies. So all the produced knowledge is shared with the stakeholder community in a knowledge sharing platform that we call the Renovation Hub. Wait, went too far. So this platform, this Renovation Hub, is a sustainable collaborative platform that has the objective of sharing knowledge on renovation packages and business models for the energy efficient refurbishment of buildings. It provides neutral and quality checked information, and our objective is to sustain it beyond the end of the project. So in STUNNING, we have first reviewed existing and emerging technical solutions for building refurbishment with an integrated approach, which means that we look at packages which are a combination of solutions that are implemented together. So we don't look at single solutions. We are now in the process of calculating the cost-benefit indicators for these packages so they can be benchmarked more easily, and all this information will be presented on the Renovation Hub. In parallel, STUNNING has also gone through an extensive process of analyzing the different innovative business models for building refurbishment in order to promote the most promising ones and support their replications. So that was for my first introduction. So I now leave the floor to Claudio Del Pero, who will present the HERT project. Thank you, Claudio.
Thank you. Good morning to everybody. So I will present the HERT project. HERT stands for Holistic Energy and Architectural Retrofit Toolkit. So here you can see some general information about the project. We started the project in October 2017. So we are the duration of the project is 48 months, and so we are more or less in this moment in the middle of the project. We are the coordinator, our university, in particular in the person of Professor Aspen. So here you can find basic information about website, LinkedIn, and Twitter reference of the project. You see here the composition of the consortium. It's quite large. We are 16 partners, and I think it's important to highlight that we are just 4 research entities, and the other partners are small, medium enterprises. So it's a consortium where there is a huge participation of small companies that are manufacturing and developing products, innovative products. Now I would like to highlight the 5 main objectives of the project. The first one is to develop a systemic and cost-optimal solution for energy retrofit. So we would like to decrease the installation time by at least 30% compared with normal construction practice, and moreover we want to ensure a payback time that is lower than 15 years. It is quite challenging if you consider the deep retrofit intervention. The second objective is to develop, update, and adapt innovative technologies for their system integration. So we are developing technologies that are already on the market, just improving such technologies, and moreover improving their integration under the technical point of view, but also under the communication point of view. The objective number 3 is to foster the building's smart upgrade. So this toolkit is intended to transform existing building into smart buildings that are interactive buildings characterized by a dynamic and multidirectional flows of energy and information. Then objective number 4, we want to support and improve the decision-making process that usually it's a challenging phase of the retrofit process of existing buildings. So with a decision support system, we would like to facilitate and to simplify significantly the decision-making process of the retrofit, and reducing the processing time at least by 30% compared to current practice. Then last but not least, objective number 5, we want to promote energy efficient financing. So the toolkit will reduce the energy consumption, but also will reduce their uncertainty on the expected energy consumption of the building. So it will reduce and minimize also the risk of the investor in the retrofit intervention. You can see here in this slide the application context. So the geographical focus is Central and Southern Europe, where building requires on average both heating and cooling energy demand, besides obviously domestic hot water demand. And the application target are multi-story residential buildings of the second half of the last century. So typically they are 4 or 5 floors linear condominium buildings, similar to those you see in these pictures. And here you can see the composition of the hard toolkit. So we have mainly 4 components. The first one is a multifunctional external thermal insulation that can be attached to the existing wall of the building, providing additional thermal insulation, a new finishing of the building, and also allowing to install a technical system such as wires or pipes. The second are retrofit components and techniques for the retrofit of existing windows, not to necessarily substitute the existing windows with new one, but trying to retrofit under the energy point of view such windows. The third one are universal PV tiles, because we know that one of the main components of the retrofit are the production of renewable energy. So we are adding photovoltaic system on the roofs through this universal PV tiles. Then we have a cloud platform that I will better describe later. Then we have direct current smart fan coils that are intended to replace existing radiators, providing both heating and cooling inside the building. Then we have a thermal storage to store the photovoltaic electricity in form of thermal energy. That is more convenient than to use battery, but in any case, component number 7 that is not developed within the project but is just purchased on the market is a battery pack, because we know that the price of the battery will decrease significantly in the next year, so the kit is already designed to be connected with the battery pack to store electricity directly. Then number 8, we have a centralized direct current heat pump that is directly powered by the photovoltaic system. And last component is the multi-input and multi-output converter that is simply connecting and powering all the other components I mentioned before. Then here you can see more in detail the structure of the cloud-based platform. So this platform contains a DSS, a decision support system, that can be used before the retrofit to, as I mentioned before, to simplify the decision-making phase. So can be used by the construction stakeholder, by the founding stakeholder, or also the management stakeholder, so to properly understand which is the best strategy to retrofit a certain building. But the same platform can be used in a second phase after the retrofit, because on the platform we run an energy management tool that will ensure the proper operation of all the technical components of the kit, and also we'll try to keep under control the real energy performance. Obviously, the platform can be connected also to external services, for example, to a weather forecast service to understand which is the expected weather 24 or 48 hours in advance, and all based on this information to establish which is the best energy management strategy for the building. So in the decision-making phase, you can see in this slide, the platform can act as an optimizer to identify the economic optimum, considering both the installation costs, so the investment cost, then and also the running costs, energy costs and operation and maintenance costs during the lifetime of the building, and then to support the designer, for example, to select the best configuration of the toolkit in that specific building. Then after the retrofit, the same platform, as I mentioned it before, can carry out a detailed monitoring of the real performances of the building, and can in real time detect anomalies or possible problems. So this will allow an immediate detection of faults, for example, technical faults, or also a detection of misuse of the building by the tenants, by the user. So by this system, it will be possible to significantly minimize, reduce the risk of the investment related to the retrofit intervention. So thanks you for your attention.
Many thanks, Claudio. Roberto Fredezzi will now present Build Heat.
Thank you, Karine. Do you hear me?
Yes, Roberto.
Oops. Okay. Here the graphics are not very good. Translate into the PDF. Anyway, we'll see. Good afternoon, everybody, also from my side. Here is the presentation regarding the project Build Heat. Again, that is a project under the Horizon 2020 program that is going to finish soon in autumn this year. The project is about deep energy retrofit of multifamily houses once again, and that takes over from some initial consideration, which is that the normally a deep retrofit process is highly invasive, because you have to enter into inhabitants, into owners' houses, It is long-lasting, so owners get bored and worried about what is happening around. And again, it's really much complex for installers because you have multidisciplinary, normally you have a multidisciplinary approach needed because you have to install insulation onto the facade, you have to install a new heating system. In many times you also have a ventilation, a mechanical ventilation needed to be installed and so on and so forth. And plus, in addition to this, everything is really much expensive. So the owners do not normally afford to pay the initial investment. And this makes everything, practically speaking, impossible, so that either, say, less challenging retrofit processes are taken into consideration, or no retrofit at all is performed. So what we thought is basically to look into, to start from this and to work on these issues, on these criticalities from an industrial perspective. Meaning that on the one hand, we develop solutions that basically do not require to work inside the building, so owners can stay in their dwellings while the work is ongoing. We develop solutions, technologies that basically bring most of the installation work, manufacturing and installation work outside the construction site in the industrial environment where everything can be well controlled and it can last as much as it is needed. And again, these technologies can be plug and play installed on site then in order to reduce as much as possible the installation time. Again, this from the technological point of view, from the financing point of view, from the investment point of view, what we are studying are also some solutions that are useful for to move the initial investment burden from the owner to institutional investors, which is again combinations of public and private financing, connected again to public incentives available in different countries around Europe, and again this moves most of the investment from the owners. This said, during my presentation I will concentrate on the technologies, which is basically starting from the I will present shortly what we have done. And then again, if there are questions, any question you can ask, or I can put you in contact with the right persons within the project consortium. So starting from the technologies and from the facade, what we developed is a multifunctional facade system, which is a macro panel, which is made of this, let me check if I can show you. Which is this aluminum frame that you see here represented, that can hold on the one hand installation, but it can hold also the cladding system, this one that is needed to cover the entire facade. The installation of the macro panel is very quick because it's made with anchoring systems, anchoring solutions that are anchored and that are fixed on the main slabs, and again in between the in the gap between the macro panel and the existing facade, what we can do is to install new pipes, new ducts, ventilation ducts and electricity cables. So in this way, basically all the new active systems that are needed to retrofit the building, they are installed outside the building itself, and the installation inside the dwelling is made with a minimum disruption. In addition to this, the cladding system can hold also the macro panel can also hold also in addition to the cladding, PV system, PV panels and solar thermal panels. Here you see an application in Zaragoza where we use this solution on a small part of a retrofitted building on the west and east side, as you can see here. And here you see the facade, which is partly covered with cladding and partly with PV panels. In addition to the facade solution, we also developed some technologies for the inside of the house, so for the heating and cooling and ventilation. And one of these solutions starts from this small size storage tank with distribution, hydraulic distribution included, which is what you see here in the small picture. The size of the tank is 140 liters, and it can be installed, and therefore is suitable to be installed in single dwellings. So it is suitable to store the thermal energy needed for domestic hot water for 1 day and for one family, basically. So we started from this solution, and we added on top of that a mechanical ventilation unit that you see here in the picture and in the schematic that is on top. So basically the mechanical ventilation is integrated into the aluminum frame of the storage tank, so that basically all the heating, cooling, domestic hot water and ventilation system needed to drive the single dwelling comes into one single compound, and basically that is say simply installed next to or hanging on a wall, on an internal wall or external wall. In an application in Rome, we are going to install it externally on the balconies, and basically that disappears in the dwelling, because what you see is basically a small opening to check and to access and maintain the hydraulic distribution. Another application, another technology we are developing is this all-in-one heat pump plus ventilation solution. The box, the big box that you see here, the size is around 1 meter by 2 meters and something, 2 meters I would say, 40 centimeter depth. That is an all-in-one solution, as I was saying, that includes storage tanks, mechanical ventilation, and heat pumps that produces heating and cooling. And what we did in the project is to connect this market-available solution. You can buy it like it is now. What we did is to connect this with PV panels, and to do so, basically, what we did is to develop a small size inverter, PV inverter, which is what you see here in the picture. So once again, the inverter is particularly small, so we did a lot of work on miniaturizing this 1 kilowatt microinverter, which then fits into the box here. And again, the peculiarity of this compared to many other microinverters that you can find on the market is that it is specifically studied for this application and for maximizing as much as possible the self-consumption of the PV electricity made available with respect to the consumption of the heat pump. And therefore, again, the microinverter talks to the heat pump and maximizes the uses of PV electricity with respect to the compressor of the heat pump, the fans for the ventilation, and again an electric resistance that is used for backupping the domestic hot water preparation. These are some solutions. Again, as you saw, a lot of prefabrication and a lot of plug-and-play installation, so to minimize the installation effort and the installation burden for the owners. Still, what we saw is that basically, despite the lot of work you can do for for preparing the installation and the reduction of installation time, there is still quite a lot of design a lot of need for coordination during the design and installation phases among all the actors involved. So much work is to be much attention and much work has to be done to improve this aspect. In addition to this, again, even though we made a lot of effort in prefabrication and plug and play and blah blah blah, what I said already, we found that installers are still lack skills in installing this kind of solution. So again, we think that we need quite a lot of work in terms of training of the professionals if we want to bring this very well-performing solution on the paper into the real world. And again, still we need to work on the initial investment cost, because the one way or the other, the owner paying the investment or institutional investors funding or financing the solution, the payback time is still an issue. People are hoping for payback times that are in the lower than 8-10 years, while we already heard from Claudio, that 15 years is already a challenging solution. So that's it from my side. I thank you for listening to me. Hopefully I wasn't too long with my presentation, and if there are any questions, I will be happy to reply to you later on. Karine?
Many thanks, Roberto. It was a perfect timing and a very instructive presentation. Roberto Lolini will now introduce the 4R in EU project.
Yeah, thank you, Karine. Good afternoon to all. First of all, maybe I would like to remember the 4 R's in the title of the project that are for robust and reliable technology concepts. That's the first point of the project. And then for triggering deep renovation, so the third R is renovation of residential buildings. So we are talking about deep renovation in residential building, and in the project we have mainly 3 groups of results, one related to technologies, one to methodologies, and the third one putting together the results of the other 2 groups to business models. So I'm going to go very, let's say, quick through the main results of the project, starting from the prefabricated multifunctional facade, timber-based in this case. So you already heard about prefabrication and multifunctional facade in the other 2 projects. In this case, we developed a timber-based one, but the concept is more or less the same. So try to integrate, let's say, new functions to an envelope system. That means, as Roberto already reminded, quite challenging from design point of view, and then in the construction side from the installation point of view. I would like also to underline the fact that there's let me say, a new step of the design process that is the prototyping of this prefabricated module before, let me say, the massive production and installation in the construction side. The idea of the prototyping is to perform tests for evaluating the performances, as well as the operational phase, let me say, the functions of this kind of system. And that's what we did for our new project. And in particular, we studied the integration of a solar collector and of a decentralized ventilation machine in our prefabricated solution. That's before the simulation and coupled with the numerical analysis. Let me say we are almost at the end of the project. We already spent something like 3 years, and one of the demo was already completed, and we are opening the second and the third. And with regard to the prefabricated multifunctional facade, the industry partner involved in this activity is developing a technical brochure in order to explain not only the part related to energy and thermal features of the system, but also other features such as fire safety, as well as acoustics, and so on and so forth. This brochure contains both general information about the features, as I said, as well as, let me say, possible configurations and physical behavior and construction details, as well as example of case studies, example of possible applications. And important as well is not only the design and manufacturing phase, but also the let me say the implementation. So in the same brochure, they are going to also to explain the process of renovation that is mainly based on digital information. So all the information are, let me say, collected in a building information modeling environment to be used not only in the design phase, but also in the construction and then in the operational and maintenance phase that is, let me say, really important for this kind of quite complex system for deep renovation. Second result I would like to present is, let's say, an old technology, a ceiling fan. What we did in this case is to work on the management and control of the ceiling fan. And the idea is to control the air velocity through the, let me say, rate of the ceiling fan, depending on the indoor temperature and relative humidity. And in this way, we can, let's say, make larger the comfort range and hopefully to avoid to use active cooling system. So, as I said, the fan is an existing technology. We didn't develop anything there, but we work for the algorithm as implemented in the remote controlled Wi-Fi connected with the fan. Third result is this hydronic unit. I mean, it is not only there is not only the hardware part, but also the software part, and so it's, let me say, a way to connect existing components of the heating and domestic hot water system, so the legacy of the existing building, as well as there's a management part with the, let's say, two main aims. One is to manage different units for the different apartments in a building, and on the other side to act as an energy meter. And thanks to the monitoring of the energy consumption, we can also predict the future consumption and manage in the best way the production component of the heating or domestic hot water system. And the main benefit, let me say, the selling points or the killer arguments of this unit are the easy and fast installation. So again, working on the timing of the installation, reduction of, let me say, disturbance and impact on the final user, and easy configuration. So to make easier the work of also not so skilled workers in the construction side, and then there could be an easy connection through Wi-Fi, and as I said, the prediction of demand profiles. From the, let's say, marketing point of view, the industry partner involved in this development is looking for a dedicated brand together with URAC, that is, let me say, the research partner involved in the development of the unit, and developing of the technical documentation, as well as of commercial agreement with other players in the renovation market, such as energy service company or utilities or engineering and architectural companies. The idea is to have this standard system connected with the other dedicated products to define a dedicated package. Fourth result, is not directly an hardware technology, but actually it is a software in order to optimize the use of natural and renewable sources in the specific location of the building. We dealt mainly with four topics: daylighting, electricity production through PV, solar collectors, so production of hot water, and natural ventilation. So in a way, these are four use of the envelope in a way in conflict each other, so in competition each other. And the idea of the software is to optimize the use of the envelope, sizing and positioning these systems in the best way. Just an example on the PV module. In this case, the idea is to we have two chances to optimize either the net present value in 25 years, for example, or other range, and to optimize the balance of the energy balance, considering the energy produced and the embodied energy to produce the PV field. So we developed a dedicated interface to play with the four modules and to optimize, as I said. This is the application for the Norwegian demo case in which we integrated in the facade the PV modules. Moving to this further result, mainly dedicated to the data collection and, let me say, effective organization of the data collected in order to provide information to the players involved in the renovation process. So this result, the sensible building data handler, is merely divided in two parts. The first one is the application to be used during the audit, energy audit phase, in order to take the information in a very easy way and to put in the information in an organized way in the building map. The second part is a dashboard. So after the renovation, after the installation of the dedicated monitoring system, we can publish the collected data to be used by, let me say, either the final users or the facility manager. So we have, let's say, easy or quite, let's say, standard presentation of information or data we collected, transforming data into information, or the elaboration, post-elaboration of this data to provide specific information, this mainly for the facility management. And then another result is procedures. So we are moving from technologies to methodologies, cost-effective audit. Also in this case, we have two main results. The first one is the audit itself. The second one is the measurement and verification. So again, before the deep renovation process, collecting data and the most of the information needed for a comprehensive, let me say, design and a comprehensive sketch of the deep renovation. So not only energy efficiency, but also comfort, indoor air quality, and so thinking not only at the energy reduction, but energy consumption reduction, but also to comfort and healthy of the indoor environment. So as I said, there are these two parts, so the audit and the measurement and verification, and this is the expected final output we will have. We already applied to the Norwegian demo case and partially to the Spanish and Dutch demo cases, and we are going to optimize the whole procedures up to the end of the project itself. So from the audit phase to the design, so we developed a specific method in the form of a platform to support the different players' interaction and cross-contamination and exchange mainly during the design and the construction phase, in order to share information and to share documentation following specific procedures. The idea is to have a repository of information and to include a specific methodology. The platform is, let me say, agnostic with regard to the kind of approach, the kind of methodology. In our case, we implemented the ForRenew methodology, but in general, the platform is developed with the idea with the possibility to implement also different kind of methodological approach for the deep renovation of buildings. And then all the technologies and methodologies are used to define deep renovation packages, and so putting together different parts, both envelope components, HVAC system components, control system components, and so on and so forth, in order to optimize, as I said before, energy efficiency, comfort, and building healthy. So the idea here is to prepare a booklet as a, let me say, inspirational booklet for designers. Last point is the reliable business models. And I mean, so the idea is to start with the existing building features and to define expected performances, and so to define the idea of objectives for the renovation. And then there are limited resources, so the most of the time you have to reduce your let me say, your requirements, and to, let's say, to compare different possible renovation packages, considering resources and possible performance. So our we are developing a specific tool, is a sort of a support tool, including not only the technical information but also specific risks related to the technology, costs, time of the installation, and impact on the environment. And so we, in a way, the idea is to be able to drive, to address the design team in different geoclusters in order to decide the best application for the specific location. Yeah, and this is just last two slides. So the main idea of the ForRenew project is to transform data into information in the different stages of the deep renovation process. And if we consider, I don't know, a cycle of 40 years or something like that, at the end of the cycle, you will start again from the beginning with a new audit and a new definition of the best technology solution for the specific building. Again, transforming data into information. So in this quite complicated sketch we defined in the proposal stage, the red arrows are the data, and data are transformed into information in the different steps. These are the 3 demo cases. So on the left, the Norwegian case already renovated, and the other 2 cases we are in the phase in which we are opening the construction sites, and hopefully by the end of autumn, all the construction sites will be opened, and early next year we will have the building renovated. Last slide on the exploitation of our results, and we decided to involve external partners in the process, to which we are going to support them in the definition of feasibility study of real case studies. So we are not going to renovate this, but also to produce a feasibility study in a structured set of workshops. So there will be 3 workshops in which we will explain and train this design team in order to define their deep renovation design. Thank you very much for your attention. I was longer than foreseen. I'm sorry for that. I'm open for any.
Invasive technologies for renovation are being developed in Europe today. So most of the remaining barriers to energy renovation are non-technical. They include, for instance, financing, also the lack of information towards building owners and their acceptance. Acceptance by building owners and decision-making process. Also the skills of contractors and SMEs of the construction value chain. So this means that in order to allow for the massification of renovation, successful refurbishment packages must be developed in a systemic, integrated and user-centered approach from design to operation, also including the production of renewable energy. They should be combined with training activities to build up skills of the construction workers and installers. They should be implemented in a coordinated approach involving all actors of the renovation value chain and be supported by innovative business models and smart financing. So the conclusions I would like to highlight today is that innovative business models and smart financing are required to support and accelerate the deep renovation of the European building stock. First, in order to move risk and financial burden from owners to institutional and private investors or banks, and also to better account for the non-energy benefits like the property value, to decrease risk and payback time. ICT tools and ICT platforms also have a key role to play to unlock the construction 4.0 potential and for renovation in particular. For example, ICT platforms can be entry points for one-stop shop approaches, which include the design, the financing, and the coordination of actors. They also facilitate the monitoring and the energy management to narrow down the gap in performance and make sure that the expected savings are realized. Finally, we have to make sure that the whole value chain is covered from planning to operation, including also quality control, and their customized service packages, which include both technical solutions and financing, have a key role to play. Now, just a final reminder that all the information we have collected so far on refurbishment packages and business models is available on the Renovation Hub that you can see here. So you can also contribute to this Renovation Hub by sharing your own success story and renovation case or refurbishment solution. For this, you only need to join the Stunning stakeholder community, so you have the link for that written just here. And we will really be happy to welcome you in this community. And now a final few announcements. First, for our upcoming webinars. So there will be a webinar organized on the 18th of June, still with Leonardo Energy, on the barriers to the deep renovation of the EU building stock and the promotion of innovative and most promising business models to address these barriers. And a final webinar presenting the stunning results, which will be in September. I also take this opportunity to announce our final event that will be held in Paris in September, on the 18th of September. So many thanks for your attention. So you have my contact details just here in case you would like to know more about Stunning or about the project we presented. And we are now ready to answer